I'll just mute it, but yeah, I'll put any questions in that Twitter group too.
Okay. So. Okay, so we should be broadcasting now. I've turned my video on. Try to make it reasonably Christmassy.
All right, I think I am now ready.
Excellent. Cool, that sounds good. So I guess we should hang around until at least some people arrive. It's a bit like having a party, isn't it? You never know entirely sure how many people are actually going to attend.
Well, it is kind of late notice, but you know, we have a recording, so I think it'll be pretty good. And yeah. I think it'll be fun, so let's just have fun.
I think so, yeah. Right. I'll just tweet that link again so that people know.
All right, so, all right, let me get my headphones. Hopefully I have them. Actually, I don't think I actually have my headphones. This is not good.
The audio isn't too bad, actually.
Okay.
Sounds good.
Oh, I found them.
Ah.
I just don't want too much background noise, but let's test this really quick. We have 2 minutes. Pushing it to the edge.
Absolutely.
All right, how's that?
Yeah, that's good. That is better, actually.
All right, great. So now we have a mic. We have this. I think my laptop is set up. Awesome. Oh, I think I need to just plug in power. And then I should be surprise free.
Yeah, I've plugged in power. That's good points.
Actually, I don't have a long enough cable, so 49% power will have to do.
If you suddenly, yeah, we'll know what it was.
Alrighty, and you can't see my messed up bed. I'm actually on vacation, so I'm trying to do this from my mom's house in Atlanta.
Oh.
All right, there we go. There, better lighting?
Yep, that's good.
Okay.
Excellent. Well, I mean, what do you think? We don't actually have very many folk here yet. Feels like maybe we should chat for a few minutes about metadata in general. Oh no, no views going up. We do have quite. Welcome to Kelsey and Anne's holiday webinar. Very good to see the numbers going up. That's very good. I hope you're all having a good pre-Christmas week. I think that we certainly are. In fact, I'm going to put on my Christmas hat while everybody arrives, just to make sure
Bah humbug.
Mood, yeah, because that's what I think about Christmas. No, it's not. I love Christmas, as you can see from all the things around me, which is in fact every single Christmas thing in my house or behind me. After it's a bare Scrooge wasteland if you walk away for a meter. But so welcome to our Christmas webinar. And what Kelsey and I are going to be talking about today is container metadata, because it is a subject close to both of our hearts, because we both think that it will play an incredibly useful role in a containerized, orchestrated future for the data center. It's deceptively powerful. It's one of the many deceptively powerful things about containers. But it's a little bit confusing because there are two types of container metadata. You've got build time metadata and you've got runtime metadata. So obviously metadata is about putting additional information, associating additional information with your container images, what you've built, your containerized application. And build time metadata is you specify it in your Docker file or equivalent. It's called a label, and the format is defined by Docker. So you can just Google Docker labels and it'll tell you how to put them into a Docker file. And they're basically there to define information that is going to be true for your built image through its whole life. So for example, almost by definition, the build time associated with when you built it is always going to be true, so that's never going to change. The code it was built from, a very useful bit of build time metadata, is never going to change. That's again by definition. There's information like who built it, again that's always going to be true. So fundamentally it's immutable information about your image. And we're part of a group called label-schema.org, which have tried to define a very non-controversial set of recommendations for that kind of really, really basic immutable image that would go into build time labels. But you don't only have build time labels, you've also got runtime labels. And in Kubernetes land, in Kubernetes speak, those are called annotations. And they are for providing information that is not necessarily immutable. It's not necessarily true from the moment you build an image all the way through its entire lifetime, things that can change. Things like how important it is to you, which might change, who's maintaining it right now, which might change through the course of its life, or depending on where you have it deployed, for example. So you've got two types of metadata, build time and runtime, both incredibly important and both at the moment rather underused. And we're not getting the full value out of them that we could. So without further ado, I'm going to hand over to my co-presenter, who needs no introduction. You all know Kelsey, the famous, well-known Kelsey Hightower, who's going to talk to you a little bit about his vision for container metadata and how it should be used, how it shouldn't be used, and possibly, if we're lucky, we might get a demo. So over to you, Kelsey.
Awesome. So I think we're probably just going to kind of keep it conversational style, because I'm also learning about how the community wants to use this metadata, right? So coming from the Docker world, a lot of people are starting to use labels and, other data, that we typically see on some type of package management system. So I guess for some of those that are probably new to this whole space, right? Because I've actually met people who've never seen things like apt-get or RPM. They only know Docker images, right? So a little level set there. I'm going to attempt to share my screen here, and hopefully you can see that. All right, so you can see my screen. So for those of you not familiar with this metadata that we're talking about on our binaries, I'm just going to jump on a Linux system. Back in the day, we were able to SSH into these machines. In this case, this is a Linux system. And I have a package manager. So before Docker, we were using tools like apt-get or yum to build these OS-specific packages. And very similar to Docker, we were pushing them to repositories. So in this case, I'm going to look at the actual package for Docker itself using the apt-cache command. So I want to look at the the Debian package for Docker and just see what's in there, right? So this is the kind of metadata that I think we're talking about when we talk about application container images and their metadata. So I'm going to run the show command. And what we see here is a little bit of details about the package. And as Anne was mentioning earlier, these are things like the target architecture for this package, the maintainer, the person you email if there's a possible problem with this particular image, things like version information, and other hints to the runtime in order to know what to do with this particular image. So in this case of apt-get, apt-get has a built-in update mechanism. So we need to give it hints on what things we should be replacing and what things we depend on in order to ensure that this application runs correctly, and things like description. So things like this totally make sense to me, and makes sense to see in the Docker container world. Things that don't make a lot of sense are things like the Docker health check package, right? So there's this health check for Docker that most people are using via a image, right? So look at the first link here, which is the risk of using this thing. So maybe there'll be an example here. But the biggest issue with this health check instruction here is essentially you can run some random bash script inside of a label. Now, if you're a runtime platform like Mesos, Kubernetes, or even Swarm itself, pulling a random image from the internet, number one, pulling a random image from the internet is probably bad in most cases, especially if you haven't really identified trust of the person who's built it. But running a command like this blindly can be quite dangerous. So things like this is what I really want to challenge in terms of metadata. Is this a runtime hint? Should it be on the image format? And should it not be pushed up higher into the runtime itself? So I actually posed that question to you, Anne. Should that be something we should consider not doing that way?
Yes, I think so. I think you're quite right that it's information that is not necessarily going to be all true the entire time that the application is running. You might want to change it. So it seems more suited to runtime. And yeah, it just seems potentially dangerous. I think we're learning still an awful lot about what we should and shouldn't do with metadata. And it's an interesting one because at the moment we're hardly doing anything with it. So we haven't really had the chance to learn lessons. And I'm sure we'll learn a lot of bad lessons first. But I don't think that your thinking on this is wrong. We've deliberately, with labelschema.org, we've deliberately kept the set of labels that we propose to go into build time quite limited. Things that are really, really genuinely non-controversial are not going to cause any problems. They're purely informational, and they're not, almost by definition, they're not going to change through the lifetime of the image.
So we were talking earlier today about these labels and what would be useful. And I know one thing that came to mind to me was, you have this Docker image, and this Docker image format seems to be kind of the standardized thing that most of these platforms are starting to use. Mm-hmm. And we're starting to see that standardized with things like OCI. So given that, most of these registries will probably be the entry point for people discovering a new application. And one idea that came up was using labels to help people get started with things like Kubernetes, mm-hmm. right? So for example, in the Kubernetes world, we push the description of the app itself into a declarative file, very similar to what Swarm does mm-hmm. in other systems. So wouldn't it be nice if we could put a link to that particular Kubernetes deploy file in the image itself, right? So this wouldn't necessarily replace what you would do with something like Helm, or if you're a system administrator, what you would put in there. So I actually had a little bit of time before the webinar, so I packaged my Hello World application. So I'm going to probably show people what I think a good way of thinking about this problem would be. So I'll share my screen again. And this time, I'm going to go to the Microbadger site. Could you tell us a little bit about this site?
Yeah, so Microbadger is a site that we developed to help people more easily look and see what metadata is associated with any public image. So you can just type in, you don't have to log in or anything. You can just type in the address of any image that's publicly available on Docker Hub and see all of the metadata that's associated with it. And in fact, all of the data that can easily be drawn out through the registry API. So what layers are in it, and you can navigate down to see what base images it's built from. So the whole idea is to try and demystify the container package that you might want to be downloading, and having a look and see what the author told you about it. So it's just a way of trying to promote the idea of having metadata associated with containers, because at the moment there's not very much, and give you some useful feedback to actually having metadata there.
So given that, it took me about a total of 2 minutes to start utilizing this. So I ended up rebuilding my hello world image, and I'm going to guys show you the Docker file that it took to do this. And in that Docker file, you'll see here's just my little hello world app that I use. Normally I build my Go applications from scratch, so they're really tiny. And to make this work, I added this label using the label instruction. And here I thought it would be cool to embed the Kubernetes deployment URL. So most people that have experience with Kubernetes, we typically install things using the kubectl command line tool. So we can point kubectl at a YAML file on disk, and this will be pushed up to a target system, right? But this YAML file doesn't exist on my system, and maybe the user doesn't really want to deal with it out of the gate. But if they're curious and have a Kubernetes cluster, maybe we could use this label here to instruct them where this configuration file is. And in Kubernetes, we can actually stuff in the service object, everything about the container. So adding that label instruction allowed me to build my container and push it up to the Docker HUD. I was able to just run a curl post against this webhook. And once I did that, my image was displayed here. So this has access to all the versions. I have a new tag called Micro Badger. So here's the latest version of it. So given that, now I can actually see here right on the website the complete URL. So you can imagine someone coming here, and what we'll do is we'll just curl it to take a peek. So we're pulling this from where the label is specifying via the URL, and we can see that this is a Kubernetes deployment object, and it's going to give me a total of 3 copies by default. And it has a few labels of its own, but these are Kubernetes specific. But it also points me to the exact image, right? So I can kind of see how, maybe this pattern could be auto-generated for people that do plan to push things up based on tags. So given that, I should be able to just use this URL to run that image. So let's give that a quick try. So we'll go over here and we'll say kubectl get pod, so we don't see anything running currently. So as a user, if you already have a Kubernetes cluster, I can imagine looking at one of these labels, io.kubernetes, mainly to do namespacing so there's no conflicts, and here deploy URL. So this is just some label that I made up, but it looks like I'm following the conventions of the community. So I'll grab this URL here, and I'll just say curl, or I'll say kubectl create-f from there. So since I took a peek already, I'm pretty sure what's in there is harmless, and I'll run it. All right, so if this works, my client will go out, fetch this deployment descriptor, and push it to my cluster. If everything is working correctly, we should see now that I have 3 of these running. And we can quickly verify that it works by saying kubectl port forward. I won't create a service for this. I'll just do a simple port forward here. We can test locally that this actually works. So we'll come over here. And we'll just do curl on that local host. And we see we get hello world. So I can imagine using labels for this kind of use case to make it really easy to point to something that has a lot more detail for the target operating system that you plan.
Yeah, and I really like that. And I think what I really like about that is that you're immediately using labels for something that maybe nobody's really thought about using them for before. And it's kind of something that people can get advantage of. They can see it there and they can do something with it, or they can choose not to. So you don't have, it's a way of providing discretionary additional information that can help people, but they don't need to have, which is, I think, kind of the ideal use case for labeling, really, metadata. So could you see that genuinely being useful?
Yeah, I think as more and more people actually adopt these container image formats going forward, so I don't know how long that will be, let's say 2 or 3 years in the future, I would imagine people will probably want more metadata, because right now, most people are just treating these things as just intermediate formats, right? I have my application. I'm only using a container because the platform is forcing me to, right? So a lot of people aren't getting any more benefits than that. And I think once we start to really rely on images for discovery, when people start searching for functionality and capabilities, I think these labels will actually help filter results, right? Most people aren't really using much search criteria. They just kind of know exactly the image that they're looking for.
Yeah, yeah, that's definitely true. It still feels like it's incredibly early days in terms of container use. There's so much that we could be doing once we start kind of waking up to the fact that it's a common format and you can write those in loads of tools, and you can write tools at every stage through, from the moment that the container is created all the way through to 3 years after it's been started running in production, whatever.
Yeah, and to be fair, I think, now that we're starting to see Docker actually actively communicating the differences between a container build, a container image, and what you do at runtime, right? So the recent announcement of containerd, right? The goal with containerd is to break out the container management layer, the thing that pulls an image, that creates the actual process from the image, are being decoupled in a way from the Docker engine itself. So knowing that, and knowing that other systems like Kubernetes or Mesos may end up leveraging some of those components, things like runc, you really start to think about the container image as a standalone thing. Most people think about the container image as a Docker end-to-end workflow, right? Not necessarily to produce an artifact that can now, if you think about it, you can use these images with App Engine, Heroku, Kubernetes. So many platforms will take those images as is. So I think as that starts to mature a bit, you'll start to see a generic use case around those.
Yeah, and for me, that's where all the power comes. The fact that we can start to move towards the incredibly sophisticated kind of runtime environments or deployed production environments that people like Google have, because they have this very standardized way of managing an application in a production environment.
Yeah, and going forward, I think people will start to talk less and less about the image itself, right? I think the image is just, again, this intermediate format. What's interesting is this concept of metadata, right? This whole data-driven deployment model. So, we were talking earlier about what other labels, once you start to believe in kind of this metadata, where else is this metadata helpful? And you mentioned earlier in Kubernetes, we use annotations. And most people are like, what are annotations, right? Because Kubernetes also has labels, but we have this distinct difference in what we call annotations. So labels would be for searching. Show me all the applications where label equals blue in a blue-green deployment or version 1. So we tend to use labels for searching and filtering, whereas annotations become hints to the runtime, right? So here is, and the runtime in this case is just not Docker. It could also be controllers. So as you've guessed, I have another demo prepared. And in this particular little small demo, I want to show you what we can use annotations for in a different system like Vault, right? So in Kubernetes, the goal is to create these pods. These pods hold containers. But we need to be able to communicate securely which containers should get which tokens or what policies should apply to those tokens. Now, the last thing we want is the user specifying that on a label on the image. This would be, security would probably just spontaneously combust if we were shipping around these kind of policies on the image itself. Number one, because it will reduce portability. How will I run this in QA different from production? So I'm going to switch over and show a little bit of the Vault controller. I won't show the whole thing, but I will show a use case where Kubernetes leverages things like annotations to give hints to the Vault infrastructure in my Kubernetes cluster. So I'll share my screen again. All right, so here I have a tool called the Vault controller. And if you're interested in how this thing works, there's a complete tutorial on GitHub. So you can just find it here under Kelsey Hightower Vault-controller. And the goal here is to automate the creation of a unique Vault token per Kubernetes pod, right? So we're going to use a few Kubernetes features, and I'm going to show you a high-level diagram of how this works. So here on the right is a Kubernetes pod, and we leverage a feature in Kubernetes called the init container. So this is a container of your choosing that gets to run. Actually, you can have a list of these containers that run in order to set up the container image or the file system or whatever you need in order to have things in place before the other main containers start running. So in this case, I'm using an init container to invoke the Vault controller. Basically, I'm knocking on the door here in step 1, mainly because I don't trust the init container. I'm not sure who it is. We reach out to Kubernetes API to actually look up the metadata for this particular pod by name. And using the IP that we get in step number 2, we can request a Vault one-time use token. So it's a wrap token, which will embed or store securely the real token. So this allows us to make sure that only our container can unwrap this. If not, maybe we have a man in the middle, we can raise an alarm. We move on to step 4. So in step 4 is where we push our wrap token to the init container using the IP address we get from the Kubernetes API, which then allows the init container to unwrap the one-time use token in step 5 and write it in place in step number 6, which will allow us to then boot the rest of the pod, and the other containers can just read the token and keep it renewed in step 7. But how does this work? How do we know how to generate the token? How do we know what policy? So in Vault, each token is associated with a collection of policies. So a token can be used to bring in dynamic MySQL secrets, maybe generate a TLS certificate from a backend, PKI backend. So what we're going to do is leverage annotations. So I'm actually going to show you a Kubernetes config that leverages these annotations. So the annotation that we're going to use is also namespace, very similar to what you see in the Docker world. So in this case, I'm going to use vaultproject.io, mainly their website URL, and then I'm just going to say /policies. I'm going to use this annotation to give me hints on what policies should be associated with this token. So I'm going to jump over to my screen now, and what we'll see is a directory of various Kubernetes configs, but we're just going to focus on a deployment object that we use in Kubernetes called the replica set. So in the replica set, we're going to look at a Vault example, and there's going to be a bunch of data that shoots out of here, but I'm going to explain everything. So there's a couple of things that are important here. Number 1, we have a list of init containers. So these are the containers that do the workflow we saw earlier. And then we have a list of containers that run at runtime that utilize the token. Now, we went into detail earlier about the token generation process, but if you look here at the annotations, which are distinctly different from labels. Again, labels in Kubernetes are for searching things. So if I have 10 copies of this app running, I can find them all by using this label in a label query. But here in the annotation, this is meant for runtime and automation tools. So in our case, the Vault controller can use these 2 annotations here. So this is the one we saw earlier for policies. And here it specifies that all the pods in this particular setup will be associated with the default policy, which will give it basic access to be able to refresh its token. Now, using this annotation is pretty much free form. I could have a JSON object here. It could just be a comment-separated list if I wanted to have multiple policies. And down here, I'm giving a suggestion on how long the actual token can live. Now in Kubernetes, I submit this to the cluster. And once it's submitted to the cluster, then we can actually look at how that is used. So I'm going to jump over to parts of the tutorial here, and I'll show you what some of the logs look like for this particular thing. So we'll look at the logs for the init container first. This is a little syntax here that allows me to grab the first pod in the list and view the logs for the init container. So when I run this command, you'll see that once we initialize, we look for an existing token. And when we don't find one, we see that we request one from the Vault controller, wait for a callback, and then we write it in place. Now, if everything is working with that list of commands, then we can actually look at the container that utilizes it. I'll do a -F here so we can follow the output. So at this point, we are printing out our actual token. Again, don't do this in production. That's pretty bad. But I'm just showing you the results of this actual secret that we got from Vault itself, which has our client token. And here I'm successfully renewing our token. So since our token has a default policy, I have the ability to actually renew it before it expires. So at this point, we're using this annotation specifically for the sole purpose of automating the ability to grab credentials for each individual pod that's spun up in a Kubernetes cluster. And I'm back.
So that was interesting because that's, if I understand correctly, that's an interesting example because it gives two reasons why you might want to, there's two different bits of information there that would be better in an annotation, would be better in a runtime label effectively, a bit of runtime metadata than in a build time metadata. So you've got information that is just too sensitive to be built into an image. And so that's better suited to a runtime label. You've also got information that you might want to change, or ops might want to change at runtime, and therefore you wouldn't want it hard-coded in. Is that correct? Yeah,
that's right. So, in my test environment, I may give my application all access, maybe a higher level set of policies, or even shrink the TTL for testing purposes, or maybe even expand it to 1 year instead of 24 hours to keep the load down on the system. So you're right. I think when people look at these, this metadata, you really have to make that decision. And I think you've hit the nail on the head. Will this data change separate from the life cycle of the image itself? And that could be between environments, between deployments, between scaling. If that happens, then I think you really should be looking at moving that metadata, maybe in the system that is controlling those aspects of the life cycle.
Yeah. And what we're not saying is that build time metadata is better than runtime or runtime is better than build time. We're just saying they have two slightly different use cases. And it's better to use the right tool for the right job.
Yeah, exactly. I definitely wouldn't want people putting get information in a pod definition or deployment definition. That squarely belongs on the image, right? The image should carry that information. And I think these runtime systems could do a better job of surfacing some of the metadata that is on those images. So that way we can give people a complete view of metadata from the pod itself and maybe metadata from the lower level image itself. So this may be possible once we get to OCI. Once we have the standardized spec, we might be able to trust that it won't change and the APIs will be stable in order to do so.
Yeah, it's interesting that there's no definition of build time metadata in the OCI V1 specification. And I can totally see that because there was a lot of stuff to agree at that point. And this wasn't the absolute first thing that needed to be sorted. But I think that there'll be more interest in it in the second release when everybody's got the first set bedded down a bit. Because yeah, you're right, it would be useful to be able to, there are times when as a runtime, somebody operating a production system, you will want to occasionally go down and dive all the way into built information for things like working out whether security flaws have materialized in the underlying images. That you're going to get that from the build time information rather than from runtime annotations.
And my guess is that if you have the image ID, then you'll be able to query it. But maybe it might make sense to really consider, setting aside a set of labels that could be possibly used, like SHA-1, git commit, time it was built. Maybe those things could be set aside to maybe get a little bit more utilization.
Yes, yeah, and so those are, I think all of those are in the v1 label-schema.org suggested set of default build time labels. And we don't think there should be that many default build time labels. Just the stuff that is absolutely never going to change. And then, of course, people can do whatever they want as well on top of that, because it is a useful tool, the metadata
Now, are you guys seeing people using the Micro Badger site? I've heard of it before, but today was the first time that I actually used it, and I can actually see how this could be useful, especially people have a richer set of labels that actually do things like give people suggested ways of deploying things. How's the uptake been?
I think we've got about 8,000 images at the moment that have the badge associated with it. So you can kind of click on the badge on Docker Hub and then see the image. So it's kind of like the people who browse the image on Docker Hub are being specifically routed to go and have a look at the metadata associated with it, which we're really pleased with, really pleased with, because we want people to be starting to think about telling their users more about the images that they're producing. We've got a couple of hundred. The other thing we've been pushing is getting people to put label schema labels in their images, and we've got quite a few hundred folk doing that now. So that's at least moving forward as well. But that's almost separate from MicroBadger. Although our original plan for MicroBadger was a badge that took people from that made it very easy to go from a Docker Hub image to the repo that the image was built from, and vice versa. And yeah, that's got a couple of hundred people using it, and we're quite pleased with that. So yes, it's there to play with. And we just added private registry support. So private registry support, yes. So to start with, we only allowed you to look at public images on Docker Hub, and we've now added the ability to look at private images, but then that's only if you own that image, obviously.
Since I'm learning about container images or using labels in this fashion, I'm pretty sure the community is too. Do we have any questions from people out there? And if not, maybe you can start with a few of the most common questions that you've seen, maybe the confusion around them, or how you're seeing them being used in the wild.
Now, I'm just wondering if we've got Ross on board, because he is the person who does this most in the wild. Have we lost him? Have we lost him? Ross, do you have a common question? What were the earliest questions that you had about this? Are you around? Have we lost you? He's probably typing some in. But yeah, so let me have a think. What were the original question? What kind of questions did we have at the start on this? Well, I mean, the obvious one is what should go in. You know, whether things like, actually a big question that I still have, and I think is a really big open question, is versioning information, but licensing information associated with a version of the code that you're building. So if you're building an image on top of another official image, which license does it actually does it inherit? I mean, if you're building on top of something which is GPL or AGPL, does that mean that your image becomes GPL or AGPL? And I still think that isn't I've asked that to various people, and I'm never getting a very clear answer. So I think that's still a bit of an open question, unless you know the answer to that, Kelsey.
Well, I'm not a lawyer, so even if I did, it wouldn't matter, I guess. But you're right, because I think people don't actually think about this. Once you start bundling, let's say a base operating system, let's say in a single layer, this may work out differently if you're linking to a base image from, let's say, the Docker Hub. Maybe you're depending on from Ubuntu, but you don't package it with your app. But I think the moment you do apt-get install, and then those things become part of your image layer, and you start distributing that, signing that, claiming ownership of that, then I think you get yourself into multiple licenses, right? Because part of that code would be GPL, Apache, along with your small set of libraries. And yeah, I'm pretty sure most people aren't thinking about that because no one really distributes those things themselves these days, right? Most people are building or have a GitHub repository with their source code and assume that the user will be bringing those things to the table. And I'm pretty sure there are some companies that have already. I've seen in the wild where most companies will be reluctant to just pull any image from, you know, a public repository. They may favor building these images themselves, going through the normal legal process, and actually forcing a little bit more constraints on what's in a base image. You know, a pattern I've seen is where there's the base image such as Ubuntu. There's an intermediate base image that is maintained by the organization that includes all the libraries, all the dependencies. And the last layer is the one that's controlled by the application developer. But again, you're distributing third-party libraries. So I think those are just things that people have to be mindful of and maybe deserves a conversation of its own.
Yeah, I think it probably does. It feels like it's a question that isn't being asked at all, and I would quite like it to be asked. Yes, yeah, there's lots of confusion there. So one of the other things Ross has popped up with, and he's right actually, this is something that confused us quite a lot in the early days, was what is the difference between, and it's something we've covered a little bit so far, is what's the difference between a label in Docker and a label in Kubernetes? Because it feels like they actually have completely different use cases, which is slightly confusing. It feels like labels progress into annotations or match up more in the flow with annotations than they do with labels. Would you agree with that?
Yeah, so I think if you think about Docker's original use case, which was to run a container image on a single system, then you had less use of searching, right? You know, the Docker Hub integration was, you know, considered something that was just kind of coupled and designed together. So I think labels in the Docker world were really meant for, you know, a single image communicating to the runtime itself. And the runtime includes build information, runtime information, distribution, where to get it from. Whereas in Kubernetes, we think of labels as a way to query and integrate other components. So in Kubernetes, to do load balancer integration, for example, we need to be able to find the collection of labels, and sometimes services overlap, right? There may be two versions of a service deployed. So we use a section or intersection of labels to say, hey, these labels equal this service. So we use it for searching and filtering, which becomes a really powerful component in Kubernetes. We didn't want people to do arbitrary expressions on complicated strings in those labels. So labels are meant to be very simple, you know, key value pairs that you would commonly write filter expressions on. Whereas an annotation is meant to be free flowing, you know, runtime specific, even meant for other tools outside of Kubernetes to understand. So we just have those two things that allow us to keep the scope small for labels.
That sounds good. Looks like we've got quite a few more questions coming in. Let's have a look. So,
I see one from Twitter. One question is there are a lot of questions about how platform-specific labels were or should be used. Now, this is a really good one. You know, we often think about everything is Linux, Docker runs on Linux, and we talk about portability. And a lot of people that manage multiple systems laugh at this, right? It's like, what is portability if your image only runs on Linux, right? You've essentially kind of reduced the scope down to a single thing, and we've gained portability maybe across the distros. So it runs on Ubuntu and CentOS 7. But that is not the level of portability people would expect, especially if you come from a compiled language. You think about cross-compiling for these targets, things get more complicated, right? There's a difference between x86 and AMD 64 architecture versus ARM Windows executable. So where, I guess in your experience, where are people putting that information?
Well, in our experience, nobody's putting that information anywhere at all. Which is one of the reasons why we started getting involved in, why we developed labelschema.org, was that people aren't doing that thinking yet, I don't think. they aren't necessarily thinking about putting that information, which would be incredibly useful to people running containers anywhere at all. And actually, a build time label is the perfect place to put it, because that's not going to change. That's absolutely how the image has been built.
So the good news
yeah.
is that the OCI image format, they actually do account for this. I remember early on, there was a bit of debates on what data should be in the API, so that on this configuration representation, what should be in there. And I know one of the things that did make it in there in the schema for the image runtime is things about the operating system itself. So inside of an image manifest, there are quite a few properties. And I think some of those properties also include things about the target OS, right? Is this a Linux thing, and what should be used there? So I'm not sure if that will make it into the final schema, but I know that you just can't take one image built for Microsoft Windows and run it under Linux, right? Those are just different things that need to happen. So I'm not sure if the goal is to either partition this at the repository. So I can imagine a container runtime going out to a registry and saying, hey, I'm on AMD 64. I require these particular semantics. Do you have an image that matches this name and tag for this architecture? And we see that for apt-get and yum today, right? If you're on a Debian system, normally it will communicate a little bit of information about itself in the URL string. So you're communicating to a particular URL template that the runtime will substitute the architecture and platform to ensure that things just work.
Yeah, yeah, and actually, yeah, that would be phenomenally useful bit of metadata to have in there, because I don't think people often realize that you can't run because they feel like something that's going to run anywhere. It's not at all apparent that a container built for Windows won't run on Linux.
I've ran into that issue myself, right? I've compiled I usually build my binaries outside of the Docker container just to keep my container small. And sometimes I'll mistakenly put in a Mako binary from Darwin into my image, and then it runs, and you get this very cryptic message about why it doesn't work on a Linux system, and you have to go in there and troubleshoot. And I get used to it now that I know I built it for the wrong target platform. But I think we need to probably sort this out on the registry side to keep users from making these simple mistakes.
Yeah, because it's something people are going to do all the time. I've done it myself as well. And yeah, I should know, I've done it in even worse situation. I've tried to run Linux containers on Windows and then been shocked when they didn't run, and then suddenly realized, well, of course it's not going to run. It's completely bug section.
I see another question. Is there a use in tools to add build labels at runtime to bridge the gap until OCI support is ready? So this is a good question. I think there should be arbitrary fields on these image formats, especially OCI. What they'll be used for, I think, will be up in the air. But again, I don't think anything's standardized there. I think a lot of people are reluctant to standardize what these labels mean. So in the meanwhile, when you create these images, I think you can use arbitrary metadata fields. No one's going to stop you from doing that. But will they be respected by a runtime like Docker or Kubernetes? That is up in the air, and I doubt it.
Yeah, it's kind of chicken and egg at the moment, isn't it? Because we need some standard or at least conventions on labels to be used so that they're then used. While nobody does, well, there are no tools that use them, and there are no people setting them, then nothing gets started. So we need to start somewhere with the leap in the dark, either putting in some labels automatically, probably through the build tools, or actually recommending them or suggesting them, if not, but not mandating them through the OCI spec.
So I see another clarifying question. By platform, people were talking about Kubernetes versus Docker. So, Docker images, the image format, the Docker image format has labels, right? And will Kubernetes respect those? And I think it doesn't make sense for Kubernetes to do anything with those labels on those images. Number one, again, we talked about the security risks, things like the health check. would be a bit too opaque to surface up into the Kubernetes API. The Kubernetes API has a well-defined set of things that we do around health checking. And that's where a user actually has a schema that's very specific, whether it's an HTTP endpoint or an exec. But we're really careful about how that stuff is defined and used. So surfacing data out of a container image into the platform, I think most people would just see that as an attack vector, right? Like, what is in those labels, and should you be changing runtime behavior for that? So I think in the world of Kubernetes, the things that are important would be maybe architecture, OS. So Kubernetes is gaining support or has support or preliminary support for things like Windows. So I can imagine where you have a cluster that's a mix of Linux and Windows hosts, that this metadata that we can get from a repository can inform Kubernetes to pull the right image for that target system. Or maybe this is something people do in the deploy description itself. But I think that's just one area where we have to be really careful that the packaging format should not have much influence on the runtime.
That seems very good. We had another question or a comment, a good comment from Ben Hall. The approach seems to be using image tags as labels, so Alpine, etc. And actually, I think that he's right that is happening, but is that the right thing? I mean, is there enough, when we've got labels, where we've got potentially a whole world of different ways that we can define, of information that we can define, do we want to be overloading tags with all of the metadata?
You know what, now that we're having this conversation, the Red Hat folks bring up a very good point. In the Red Hat world, they do a really good job of preserving the RPM database. So this is all the information about every package that's installed in the image. And you can imagine a world where you take your application and create an RPM for it as well, specify your dependencies, the other external dependencies in your RPM like people do today, and just use RPM itself and the yum commands to build your container image. And in that way, you can actually reuse the RPM database to give you a real semantic view of what's in the image. Because I think a lot of this is alluding to what is in the final image that I'm running at runtime. When you add in all the layers, what is the complete story? And right now, most people can't see that. So while I agree that you could probably use images like the way we're talking about, you know, Red Hat, blah, 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 but what's really in there? Can you trust that? You know, things like the RPM database that has all the signing information, the checksums for the binaries, is that a valid approach? If you're going to go into this world of using base operating systems to start your build process, then why not re-leverage their existing metadata that's inside there that gives you a complete snapshot of everything that's running inside of your container?
Yeah, that is an interesting point, actually, because to a certain extent, we're reinventing the wheel. This has all been thought of about. It's a shame to just throw all of that thinking away, isn't it?
Well, that and the fact that we're not necessarily packaging all of our dependencies in a way that we know the metadata. For instance, are you going to add metadata about the libc version, libssl version, the Python runtime that you're just inheriting from the base OS?
Yeah.
And by the time you do all that, you start to really defeat the purpose, because you're gonna have to do that for CentOS, you have to do that for Debian, and I think it's a lot of work. I subscribe to the world where I'm trying to use tools that move away from the distros in general. You know, there's tools like Buildroot, which you get a little bit more explicit, and you explicitly specify. It's like homebrew in a way, but for these small embedded systems, where you can go and say, I need Python version 2.2 or 2.7, and in that world, it will then build only the things that are required by Python and kind of give you a printout of what all of those are. And maybe you can take a holistic approach and say, in this image, here's every single thing that we have and its recursive dependencies in the way you can communicate.
Yeah, that is interesting. How do you see containers going? Do you see containers being something that become more mysterious or less mysterious? So what you're describing is a world in which that you've got an awful lot of an awful lot of information about what's in any package all the way down, and you can keep following it down and getting more and more information out. But almost containers can be viewed as a kind of a black box in which you just get it and you accept it, and whatever's the official image, you just run it.
Yeah, so people go to jail for that, right? Like when you go black box with your software, you're going to get in trouble, right? Because if you don't know that you're vulnerable to particular things. So one thing that we all take for granted is that the distros have done a fantastic job in being adults about software, caring about things like licensing, updates, security lists. These are things that just don't exist in the container world yet, right? They're scanning tools, but where are they getting their information from? You know, a lot of these companies in the container community don't maintain these security advisory lists. They don't actually do the patching directly for all of these dependencies. So you're left in a world where you have, you know, half the solution that we had before. So we really need to think about, you know, this black box. I think in lower environments for testing on your laptop, even that could be very risky. But this black box approach, I don't know if it will scale into maturity, right? This needs to be really taken serious when you start to get to production and things matter. So a lot of sysadmins were raising these issues years ago, right? And, you know, people's like, hey, this is the new way, you know, get with the times. But when something happens, someone has to be responsible. And I think what you will see over time is that the container image will definitely continue to have a lot of value in providing a common format for these runtime systems. But I think we're going to raise the bar on what we expect either from the language runtime, like Golang gives us a very easy way of building a self-contained binary and vendoring all your dependencies. We also see a little bit of this in the Node.js world. And I think we're gonna have to figure out how to surface that metadata through the container image so I can actually know what's inside versus relying on an arbitrary set of labels. As you know, most people don't keep arbitrary things up to date. So you're going to have a mismatch on what's in reality and what's in the label. Yeah,
and in fact, we've already seen that. If you look on Docker Hub, when I said that only 4% of images had correct labels, there are about 8% of images that have labels, but 4%, so half of the images that have labels, they're definitely wrong. They've been inherited from a base image, and they definitely don't apply to the final image. So we're already seeing a world in which people aren't thinking about it and they aren't maintaining their metadata. 50% of people who are putting metadata in, it's incorrect metadata, which is arguably worse than no metadata at all.
So we need to automate that process. I can imagine a build step that goes through and basically looks through everything that's in all the other layers and pulls out the right information that you could easily attach last mile to the image to make sure it's automatic. Because if it isn't automated, I don't think we're going to end up in a good place.
I agree.
I think in addition to this would be some tool that would help people manage their labels in a way that's just fully automated and trustworthy in a way that we don't have today.
Yeah, I totally agree. I mean, I think we've got two problems, which is one, nobody's really setting metadata at all, but then as soon as they start to, they set it wrongly. So it's kind of, yeah, we've got two problems to address, and a decent build system that everybody agreed to adhere to would solve both of those problems. And it's probably the only real solution to both of those problems. Some build tool needs to come along and do it. Have we got any more questions?
I think we should take one more. I think we have about 5 more minutes.
We got. Yeah, there's somebody saying maybe the manifest is the best place to store all metadata, and I don't think we'd have any objection to that.
Well, you know, I just think.
Well, so all build time metadata, sorry.
Yeah, I think we just really need to think about software build practices in general. You know, they haven't been improved very much, you know, since, you know, years and years and years ago. There has to be a better way of surfacing this metadata. And, you know, I think the reproducible build community is on the right track. They want to make sure that you can reproduce the software bit by bit when given a specific set of your application and its dependencies. And I think once you're able to do that, we need to be able to capture that information in a way that can be queried, because if you do that, then I think you can actually build these better security tools and scanning tools and licensing checks and enforcement, right? In order to do that, we need to do the same thing we did for building and running an image. We need to also make sure that they're easily to inspect and verify. So I think that's kind of the next challenge if we want containers to continue to be a thing in the future, because the serverless folks are reducing the scope of things that you need to put into that particular envelope or image. So, there's a race going on between the people who believe we should just be shipping the smallest amount of code possible versus shipping the entire world side by side with our application.
Yeah. And I think that's probably a good point to leave as we come to within 4 minutes to the end of our talk. So in summary, we think in summary, metadata is still at really early days. I think what's been demonstrated by our conversation today is that there's no consistent view about where metadata should go, how it should be used. We all know that we need to come up with a more consistent view. And we know that we're quite happy with the idea of build time metadata and runtime metadata, and that's probably the right paradigm to be going along with, throwing neither out and not attempting to merge them. Would you say that was true?
Yeah, I think that's a good observation. I'm glad you guys are doing this work because, as you know, the container community is big, it's diverse, but we need smart people working on even these type of details. Some people will consider this way too low details to be useful, but the thing is, it's important. So I'm glad you and your team are so laser focused on it.
Hopefully we'll be able to keep with laser focus on it. Anyway, well, thank you very much, Kelsey, for giving us your time on your holidays to talk about metadata and containers, and have a absolutely excellent Christmas and New Year.
You too. Thank you.
Cheers. Bye-bye.